All right, so it's Saturday. I think on Fridays, Zooms, the wrap-up Zooms, they're gonna have to be done. I gotta have one night off, so they gotta be done on Saturday. So here I am. It's Saturday about 1:30, and Pepper's asleep down there somewhere. Where's old Pepper at? She's in front of the heater. There she is. So Pepper's asleep and ready to do a little bit of work here. So I'll share the screen. Just be patient. I keep hopefully improving the Canvas experience and improving the Facebook group experience. We're up to about 75 members, and so I think I'm ready to start putting units on there and also keys where we can actually discuss under the key and also under an assignment. Because I don't think about the Canvases. There's a discussion area on there, but I don't think that it's very conducive to having it all right there. Like I want to have the sheet there, and then the comments below, you're asking me questions before it's due. 1.2 was due last night. Remember, on those things that are being turned in, and this also holds for when you turn in your packet, I'm looking for effort there, solid effort. And if I see effort on all the problems, and just give it out, just did blank, then you're going to get the credit. The only time I really judge you on whether you're right or wrong is on tests. So that's on quizzes, which you get right now, like at least 2 chances to do it. And then on take-home tests, which you have all the help you want, including me, on. But the only time you're going to have no help and you're on your own will be in-class tests. And the first one of those is October the 8th. So, all right, so I'm going to shut up here and go to the screen share. All right, so we have 4 panels of 4 sheets from Friday. We spent the first probably 2/3 of the class, at least, maybe 3/4 of the class, going over sheet 1.3 in the metric game. And so if you missed it, there's a pretty thorough, right here, there's a pretty thorough, put it right, so I'll show you. Here, pretty thorough help video there. It's old school. It's me talking. It's not silent, and it's probably adequate. It would be enough for you to figure out how to do these. I mean, I'll go over a couple of these in this little review. Here's the answers for 2 through 10. This is actually what the class went to the board on. We did one. I don't know if I have 1 through 9. Yeah. For some reason, I didn't include 1 through 9, but anyway, here's 2 through 10. There's 5 examples there for you. We did 1 through 9 in class. I will post a key on this probably Monday night. I want to give group 1 a chance to come in and ask questions, and then I'll probably post a key on this on Monday or Tuesday night. But this is not a sheet this 1.3 right here, this is not a sheet here that you will take a picture of. Some people have, but I mean, that's fine, doesn't hurt anything, I suppose. And then they submitted it, but it's not going to go into the grades yet. I'm going to wait until the paper packet. So on these packets, like some sheets, maybe half, maybe a third of the sheets, you'd actually take a picture of and submit to kind of keep you honest, keep me up on grading and keep you honest on doing your homework. But some of the sheets you'll keep working on, but you'll collect them. And then on October 8th, I believe will be the day, you will turn in the packet. That's the day you take your test. So you use it to study with, and you'll turn in the packet. Plus, it allows you to have the sheets at home. When the key's posted, now you have the sheet to look at. So if you want to try 2 through 10 even, the homework assignment is, for those that are gone, homework assignment is to finish 1.3 tonight. or this weekend, so that Monday we're ready to maybe quickly go over it and then move on. So here's some more. It looks like here's some more 5, 6, 13, 14, 17 from sheet 1.3 that are worked out. But basically, let's go back and we'll do one here. I don't have sheet 1.3 in front of me, but let me pause it here, see if I can find that sheet. All right, so here's the sheet 1.3. So we did together in class, we did 1 through 9 odds, and then I sent them to the board to do 2 through 10. Then we talked about it some more. But let me go over, since for those that weren't here or those that need a little more help on this, let's go over a couple of these. How about we do, let's try 13, because we didn't really get to one like that. Let's try 13, blow this up. All right, so for 13, if I'm gonna play the metric game, and the metric game is, it's really kind of a goofy little game, but it's designed to get you to start to understand what these prefixes mean and to get them in your head, and also talk to you about scientific notation, that kind of thing. So on 13, now the way you start all these is you go ahead and write these in proper form. So this would be 1.226 times 10 to the, and my game, I always make it a yellow box. You don't have to make a yellow box there, but the name of the game is to fill in the yellow box. But so the question is, why did I do this? Why did I make it 1.226 when it's 12.26 over here? Well, this is called proper. This is the proper notation. So proper notation in scientific notation is to show the decimal after the first digit. So it's digit, decimal, digit, 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 if that's what you're looking at. We also talked about significant figures some on Friday, and that also comes into play. So you can't really talk about scientific notation without talking about a little about significant figures. And significant figures is a way to be honest with your numbers. It's a way to show that, yes, these are measured numbers, and this is how accurate I think I can be. Okay, so you're not lying to the reader. So this, for whatever reason, when this was written here, this 12, it was written incorrectly. So we got to fix that. And sometimes people do it on purpose because they're comparing numbers, but the standard form is to put the decimal after the first digit in scientific notation. It's like the standard way to do English is to capitalize the first letter of a sentence. Occasionally a poet or whatever won't do it that way, but this must have been, this person must have been a poet from physics. Okay, so the way you play the game is, we have to we're trying to write this the correct form. We have to compensate for the changing of the unit here. Okay, we went from meters to micrometers, so we gotta compensate by that by changing. Basically, it's moving the decimal around. But this old business of doing this, remember this back in elementary school or maybe in 8th grade or something, we used to do this. You'd move this guy like that, or you'd move him like that. No more of that. No, no, no. Don't do that anymore. If it's just a couple of moves, maybe, but it gets out of hand pretty fast. So here we go. To do this, I'm going to write a 1, and what I'm writing above these numbers is powers of 10. So I'm saying that I wrote the number as 1.226. It's actually 12.26. So this is a reminder for me to take into account that I did move that decimal over. This, I'm just going to circle it because I don't want to forget about it. This meters is at the base unit, so I'm just going to put a 0 above that. That's like on the top of the page of the back of this worksheet, you see a power line. And so meters is the base unit on the length of power line. You can also substitute in M up there. You can substitute in liters, capital L. You can substitute in G for grams if you're looking at mass. You can substitute in hertz. for frequency. We do a lot of talk about frequency. So that's the cool thing about metrics is the prefixes go with anything. It's a really smart system, and that's why the rest of the world has adapted it, but America has not. All right, for this one I blame on Ronald Reagan, but anyway. So micrometers here is a negative, and I voted for him in 1980, -6. See, it's because a micrometer is a millionth of a meter, so that's 10 to the -6. I put a -6 above that. And the way we play the game, I add all of these on the left side of the equal sign. I subtract everything on the right. So it's 1 minus 3 is -2. Minus a -6 is like saying +6. That makes that a 4. And that's how you play the game. Let's do another one, huh? Let's go ahead and try, let's try 15. Okay, so since it's sitting right here. So the first thing I want to do is going to go ahead and write it the way I'm supposed to be. 1.2 times 10 to the yellow box. And it's already in the 1.2 format, and that's good. So yellow box here. Now I go through with my numbers. Well, that's good. I don't need to put anything above the 1.2. The -6, I'll circle it so I don't forget about it. This mega means 6 megahertz. Kilohertz, like on your radio station, radio waves that are in the kilohertz range, those are your AM stations. Radio waves that are in the megahertz range are in the FM station, the frequency modulated station. K kilohertz here, so this would be going from an FM situation to an AM situation, or referring to it in terms of kilohertz. So this is a 3 above that, because kilo means 3,000, 10 to the third. So now I add up this, -6 plus 6 is 0, minus 3, so I get a -3 up here. So you could, for those of you that look at this and go, well, look, I could do it in my head. I don't have a problem with that, doing it in your head. It just eventually, at some point, it gets kind of rough to do it in your head on some of these. Let's try the next one. We have 4.5, it's written scientifically correctly, times 10 to the yellow box. Yellow box, okay. So now that's already taken care of, checked, I guess, for nothing. -8 there, giga is 9, and then micro is -6. So this one may not be quite so easy just doing your head, right? It's probably better to have a little system like this. So we get 9 minus 8 is 1, minus a -6 is like saying +6, so we get 7 right there. And thus, that is the metric game. Now, there's also, you had to do this one, 21 through 27. That's also, quote, due Monday. I mean, I'm not saying you're going to turn it in on Monday. We're not turning this sheet into the 8th, but to keep up with it, to keep up with the work, you want to also have this done. And I'll post a key probably Monday or Tuesday or at the latest Wednesday evening. So just probably Monday or Tuesday night, so that you have something to check your work with. And physics, you just can't let slip. You can't say, well, I'll let that slide, because we'll be on to other things. And then you're going to get way further and further behind. You start to lose hope. So hang in there. Keep up with it. At least trying everything. Do your 20 minutes a day or something. All right. Let's try one of these. How about 23? Let's try 23. So it says, how many micrometers are in 4.7 times 10 to the -12 megameters? Well, see, it's kind of the same way. We're just writing it out differently. We're putting it in sentence form. So I'll write my answer as 4.7 times 10 to the yellow box. Yellow box. All right, so let's take a look. So I have a -12 here. 4.7 is cool. Mega is 6, and then over here we have -6. So now I'm going to add these two, and then I'm trying to find out micrometers. So this is micrometers. So I play the game. 6 minus 12 is a negative 6, minus a minus 6 is 0. So the answer is 4.7 times 10 to the 0 power, or that's the same thing as saying 4.7 micrometers. You can leave it either way. But that's kind of the method you use for these last problems. Okay, so now moving on here, there's the page we just did, okay? And then here's a question, like, what is this? Because it came up in class, why can't we just kind of show it with all the zeros? Well, it's not very, that's one reason why I use scientific notation, is so we can avoid having to write all the zeros. This, by the way, this is Avogadro's, oh God, it's been years, Avogadro's number. Remember, a mole, particles in a mole. So you don't see it written this way, right? You always see it as 6.022 times 10 to the 23rd, I believe. It's 20, I think I got it right. I think that's 23 zeros. I hope that's close to it anyway. So that's an example of where you don't want to write the whole number out. I think the article I put on the Facebook group has 10 to the 1100th, and that we're talking about how many years we have, I think, or whatever, until the universe starts to go, all that's left are brown dwarfs or whatever the article showed. But it was trying to show a huge number. So if you wrote that number out, you would do a whole page of zeros. So scientific notation is good for really big numbers. It's good to show accuracy, how significant your digits are, how accurate your number is. And it's good to show some really small numbers. So an example, here's an example of another pretty big number, and that's speed of light. So that's not as bad. So the rule of thumb is, this is my little symbol for a rule of thumb. The rule of thumb on this is 5 leading greater than, 5 leading or trailing zeros. Now, when it's a rule of thumb, it means it's not always true. There are exceptions to the rule, but the general rule is that if you have, it's okay to write down 5 trailing zeros or 5 leading zeros. That's pushing the limit right there, okay? Sometimes in a book, they're trying to emphasize how big the number is, so they'll just write all the zeros out. But normally, if you're communicating scientifically, you write it in scientific notation for large and small numbers. Here's an example that you learn from chemistry. This is the size, the mass of an electron, right? Well, that's 10 to the negative 31st kilograms if my chemistry, I haven't taught chemistry in 20 years, but if it hadn't left me totally, I believe that's the correct, very small, the point is. Well, I don't know, I think I counted 31 zeros here, but look at that. Who's gonna write the number? Who's gonna write that number like this? I mean, this is dumb. It's insane to do that. So another example of where you want. And then I want to show you this. Okay, so this we started talking about, but we didn't do that much with it. We had some verbal conversations first, second, third hour on this idea, but then I went down, I think, so, oh, here's something. On these Zooms, on the wrap-ups, I was putting bullet points, I was putting screenshots, and I was putting this Zoom wrap-up video. Well, I think instead of doing bullet points, I'm just going to annotate the screenshots, and that's what I did here. I annotated this screenshot. It's what we talked about verbally, definitely in third hour. We mentioned it, I think, in second. You know, sometimes the day goes on. Sometimes people ask questions and things come to mind. So probably the class that will be the closest to what it ends up being will always be third hour. By third hour, I have kind of adjusted. So when you're watching these, you're getting the best of first, second, and third hour. Anyway, so on this one, if you're talking about your bank account, this is another reason why you would do scientific notation. Because if I just say, how much money you have in your bank account, and I say, I don't know, $500. Well, that's probably, only has one significant figure, And significant figure means I'm sure of that digit. I'm sure about the 5, pretty sure. I mean, it might be 480, it could be 540, but I'm pretty sure if I say about $500, then I have confidence that it's around 500. But I certainly don't know if it's 510 or if it's 490. So then if I say, if they ask me, well, what if, how much money do you have in the bank? And I say, well, I have $500 plus or minus $10. Like I know I'm pretty sure about the 5 and the 0.0 there on this scientific notation. That's my first iffy. I'm not real sure about the tens. I think it's around, but it's going to round to 500 or 5.0 times 10 to the second. So I have confidence in that I'm closest to the nearest $10, I think. So I'm probably between $495 and $504, somewhere in there. Then if it's 5.00 times 10 to the second, if I can give the number in that much accuracy, now I'm saying I know every single dollar, right? I mean, it must be close to the end of the month here because I know how much money I have in the bank to cover all these daggone bills. So down to the dollar, I know it's not 502. I'm telling you, when I write the number like this, I'm telling you with confidence that I have exactly $500 in the bank. Yeah, and then finally, if I'm going to get to the nearest dime, it's 5.000 times 10 to the second. Because now I'm even sure. And then if I wanted to the nearest penny, you're supposed to fill this out, but I'll fill it out here. And this would be 5, you probably guessed this one, 5.0000 times 10 to the second. Now there's other ways to do it for this one, and this one. You could write it like this. You could write this as, let's get a different color, okay. You could write this as 500 point. This is something I started doing about when I started teaching, about 35, 40 years ago. They started saying, okay, let's just be the shortcut way. Instead of writing as 5.00 in a second, we can just say 500 point. When I put that point right there, that makes these zeros significant. That says, okay, I'm sure down to the dollar how much money I have. If I know down to the dime, I would say I have $500 point O. If I know, where my dime is, I know it's exactly $500 in there. So whenever there's an actual digit there, like a 1, 2, 3, 4, 5, then I'm going to assume that the person that wrote it knew that that's what it was. But the zeros are the placeholders. The zeros are the tricky ones. And then this could also be written here down below. This could be written as 500.00 if I know exactly down to the penny how much money I have in there. Exactly $500. All right, that's enough of that right now. I introduce these kind of ideas early. We're not going to have to really get into significant figures for about another couple of months, but there's a little preview for it. That's a preview. Would it be on a quiz? I'm going to stop calling them exit quizzes. Just call them quizzes. So yeah, it could be on a quiz, but you would have this to look at. Okay, and then the last little set of panels here. We spent the last 10 minutes of class talking about vectors versus scalars. And I showed them this list. And then I said, okay, what do you think the differences are? And all of these are scalars over here. And then the right column is all vectors. Vector is not necessarily superior to a scalar. I think displacement is certainly superior to displacement in physics as the concept is certainly superior to distance because distance kind of tells you how far you went. But if someone asked me, well, how do I get to the Warren Theater? And I told them to go 7 miles and then walked off, that wouldn't help them a whole lot. They don't know whether they go east, south, north. But if I said go 7 miles south on north on I-35, then that would get them a lot closer, right? So displacement vectors are arrows. Vectors have a not only a length but also a direction. So velocity then is the 10, these are the $10 words, and speed is a 10-cent word. Okay, 10 cent. Distance is a 10-cent word. This is a $10 word. Because speed can tell you how fast you're going, but velocity tells you how fast you're going and in what direction. And it may be north or south or east or west, but it might be 20 degrees south of west, you know? So speed is the magnitude, how long the arrow is. But but vectors, or velocity in this case, is the arrow. Okay. But then you get down, so you think, well, that gives you the impression that vectors are superior to scalars. But then you get down here to these, and all these down here, we get down to like kinetic energy, gravitational energy. These are huge concepts, potential difference. Then you get some even some electromagnetism there. But so no, vectors are not superior to scalars because let's take, for instance, energy. So kinetic or potential, but just energy in general. So the question is, which way does the sun shine? Which direction does the sun shine? And I asked this in class on Friday. And the answer is, of course, it shines in all directions. So the thing about a vector is, yes, vectors are really cool, but vectors, so sorry, the sun radiates. So vectors can only give you one direction. It has to be a one direction arrow. So yes, vectors are in some ways are superior to scalars, but in some ways are inferior to scalars because vectors limit you to one direction. Whereas a scalar could be just a point, it could be just a magnitude, but it could be something that's radiating. So yeah, so when I first started teaching, I kind of poo-pooed scalars a little bit, but then I realized, oh my goodness, no, scalars are also really important. Okay, so let's see. Okay, so here is back to vectors here. So a vector is represented by an arrow, and I added this Friday afternoon. So, and this is what I mean by annotated screenshots. So instead of adding bullet points, I'm going to do more screenshots like this where I'm annotating it. So here's a basic vector. All these vectors have a head and a tail. Now we're going to do something. We're going to add vectors that have head and tail. Here, it'll be a while. I'm introducing it right now. We're not going to get into adding up head and tail till probably, good grief, I don't know, late November or something, till we get serious about it. We'll play around with it, but I mean serious about it. All right, all vectors have a head and a tail. And then back in my college days, so old I am, we used to actually draw the feathers back there. And then the head, notice that the head is only half an arrow right here. And that bothers students. So why do you make half an arrow? Well, that's not going to come clear until we start adding them up. So like when I add up vectors, now this is not adding vectors, this is a head-to-head method. But say the red vector here is my resultant, and this is terms we'll use later. The blue is one of my one of my vectors that went into it. Say it's a free body diagram of a car driving up a hill, and we add these forces up, these arrows. I'm getting ahead of myself. The point is that we make these things half an arrow because when they do end up going head to head, you want to have room to put your angle in here. Same thing with tail to tail. Excuse me. So the last little shot here before I wrap this thing up, I've gone too long, is this is where Pepper lays beside me by the heater when I'm making my help videos. As long she doesn't like the cold. She doesn't like the cold very well. So she'll lay down and take a nap beside me. So there she is, Pepper the Wonder Dog, our mascot. All right, so hope this helps, and I'll talk to you guys on, let me stop the sharing. All right, so I'll talk to you guys on, well, Facebook or Facebook preferably. I'm going to work on that today, and hopefully I'll put more units so it's more organized. I had a couple of questions from students that I've tried to answer on there. and I'll try and get to your answer pretty quick. I get notified that you asked a question. So it's a little bit better at that, I think, than Canvas is. Plus, when I answer your question, everyone can see your question, and that's good. I mean, don't think that you look dumb asking a question. The smartest students are the ones that ask the questions. So, so ask your questions there, and then everybody can benefit from the answer. I mean, if it's all done through email, then I'm going to be answering the question up to 83 times. That's extremely inefficient, and it'll drive me crazy. So if I can just answer you, and then if anybody else asks it, well, I'll refer them back to our conversation. See what I'm saying? All right. So help other students by asking questions. All right. See you guys.